Hello students, welcome back to Programming in C language. Myself Sreekanth. We are discussing about what? Computer fundamentals. Okay. See the agenda of this session about solid state storage. Okay. See we discussed in the previous video sessions clearly about various memory hierarchies like registers, cache memory, main memory, and a magnetic disk and a magnetic tape. So these are all what secondary storage memories. Okay. So in this session, we try to continuation of discussing about what memories, that to be what solid state. In previously we discussed about registers, primary storages like RAM, ROM, cache memory, and virtual memories. The secondary memory is like magnetic and optical storages. The magnetic, again magnetic tape like cartridge drives, cassette drive. In the magnetic disk like floppy disk, hard or fixed disk. In the optical, we discussed about CD-ROM, DVD-ROM, and a Blu-ray disc. So in this session, we try to discuss about what a solid state storage like flash or pen drives, memory cards like SD cards, MMC cards, we try to discuss, right? Okay, secure digital cards and multimedia cards we try to discuss in this session. See, what is this solid state storage? See, a solid state storage is one of the latest secondary storage devices. See, this type of storage is also called what? Flash memory. Okay, this type of storage is called what? Flash memory. It is a permanent storage device. Data will not be erased even when the power is what? Switched off. That's what we may call it. It is what? Non-volatile. It is a permanent storage device. See, we may also abbreviate it like SSS. Solid state storage is a type of non-volatile computer storage that stores and retrieves digital information using only electronic circuits. But in previously we used what? Moving mechanical parts, optical, like traditional electromechanical storage, records data using what? Rotations or linear moving media coated with what? Magnetic material. See, but coming to what? Solid state storage, SSS, is a type of what? Non-volatile computer storage that stores and retrieves digital information using only electronic circuits without any involvement of moving mechanical parts. Traditional electromechanical storage records data using rotation or linear moving media coated with what? Magnetic materials. So it is what? Permanent storage device. Solid state storage device what? Typically stored data using what? Electrically programmable non-volatile flash memory. The solid state storage is much faster than what? Traditional electromechanical storage. So it is what? Non-volatile. Non-volatile means what? Data will not be erased even when the power is what? Switch off. Flash memory is an electronic non-volatile computer storage media that can be electrically erased and reprogrammed. So this is about what? Solid state storage. It also what? Secondary storage. Again, it consists different types like what? Flash drive, also called pen drive. Memory card, it comes under what? MMC, multimedia cards, and SD cards, secure digital cards. These are all what? Different types of what? Solid state storage. We'll discuss one by one. Okay. Yes, coming to the flash drive, also called what? Pen drive. So you're all familiar using nowadays about these flash drives or USB flash drives or pen drives, right? For storing the data, getting the data, retrieving the data for several purpose, for data storage, audios, videos, images, like multi-purpose. We are going to be store the data in what? USB flash drives. See, it is a compact device of the size of a pen, comes in various shapes and styles, designs, and may have different storage capacities. Several features it includes, okay, like it enables what? Easy data transmission from what? One computer to another. So it is a plug and play device that simply plugs into what? USB port of a computer. The computer detects it automatically as a what? Removable drive. Okay, so we can easily read, write, copy, delete, or move data from the computer's hard disk drive to pen drive and vice versa. See, it does not require any kind of external like cable, battery, or software, and is compatible with what almost every PC. It has very compact size and very low energy consumption. So it stores data what permanently. For that we may call it is what non-volatile in nature. USB flash drives have lesser storage capacity than and what external hard drives, but they are smaller and more durable because they do not contain any internal moving parts. See, as a flash memories do not have any moving devices like heads, arms, and so on. In the previous session I explained clearly about what, like how this hard disk is going to be working, like spindle rotations, okay, head, like accutators, like different kinds of things are there, but in the flash drives not required for all those things. Okay, yeah. So it is available the storage capacities like what 512 MB, 1 GB, 2 GB, 4 GB, 8 GB, 16 GB, 32 GB, 64 GB pen drives are available in the market. See, in future it may comes like 128 GB like that. It's going to be extended what storage capacity of what flash drives. Simply the flash drives looks like that. It is durable, portable in nature. Okay, it is not required any external or additional softwares and additional work involved. Simply connect with what USB. So these are all the points I added here. Simply I can tell it enables easy data transmission from what one computer to another. So it is a plug and play device that simply plugs into what USB, universal serial bus port of a computer. See, we can easily perform what read operation, write operation, copy operation, delete operation, or move data from what computer's hard disk drives into what pen drives, from one disk into like any kind of external disk into what pen drives. We may happily transfer the data. We can perform several data related operations like read, write, copy, delete, move operations. We can do it. Okay, data related operations. So it is more compatible comparing to what previous memory storage devices. So it's non-volatile in nature. Once data is stored, it cannot be lost. Okay, it is faster than what mechanical disks. Its storage capacity, it varies for what some MBs to what GBs. So it is an advanced version of what EEPROM. Okay, so already we discussed electrically erasable programmable read only memory. So it is an advanced version of flash drives or what advanced versions of what EEPROM. So it stores information is an what arrangement or array of memory cells. Okay, so remember this point, array of memory cells is a contiguous memory allocations. So made for what floating gate instructions. Okay, the advantage of using this memory is that you can delete or write blocks of data around what 512 bytes at a particular time. See, whereas in EEPROM you can delete or write only 1 byte of data at a time. So this is a memory is faster than what EEPROM. See, in the flash drives we can able to do 512 bytes at a time, particular time. We can delete or write blocks of data around what 512 bytes at a particular time. But coming to EEPROM, it can able to do only what we can delete or write only 1 byte of data at a time. So this is the memory is what more faster than what EEPROM. See, coming to history, flash memory invented by what Fuzio Moscow at Toshiba in the year 1980s. Okay, and in the late 1980s is a form of what EEPROM that makes very efficient use of what chip area and can be erased and reprogrammed thousands of times without damage. So it permits and reprogramming of only a specific part of the device instead of the entire device. This can be done at what high speed, hence the name came for what flash. See, the performance is what very high, that's what the name came for what flash. See, the most recent development is what? NAND flash. Okay, also invented at what? Toshiba. See, it's a designers explicitly broke from past practice, stating plainly that the aim of NAND flash is to what? Replace what? Hard disk. See, at present we are going to be using what? This internal hard disk and external hard disk, right? So the main intention for NAND flash is to replace what? Hard disk. See, this is about what? Flash drives. See, at present we are using, it is available in the market with the various sizes of what? Storage capacity like 512 MBs to GBs available in the market with the different sizes and different companies. Okay, so this is about what? Flash drives. So next, coming to the memory card. See, what is this memory card? See, a memory card or flash card is an electronic flash memory data storage device used for what? Storing digital information. See, some of the most popular ones are, excuse me, like SD secure digital and MMC multimedia memory card. Storage capacity of these cards ranges from what? MBs to what? GBs normally. So this is about what? Memory card. See, they are commonly used in what? Many electronic devices including digital cameras, mobile phones, laptop computers, MP3 players and video game consoles. See, they are what? Small, re-recordable, and they can what? Retain data without power. See, this also facilitates easy transfer of data from these electronic devices to what? Computer and vice versa. See, this is about what? Memory cards. Generally, it categorized by what? MMC cards and SD cards. MMC stands for what? Multimedia cards. SD stands for what? Secure digital cards. See, several things are there like RSMMC, reduced sizes, DVMMC, dual voltages, eMMC, embedded multimedia cards like SSD, solid state drives, USB flash drives. See, these are all what? Different kinds of what? Types of what? Memory cards. Okay, like what are the various memory cards? MMC like multimedia cards, SD secure digital cards, SSD solid state drives like a USB flash drives. These are all what? Various types of what? Memory cards are available in the market. Okay, so we'll discuss one by one about what? MMC. Okay, see, multimedia card. See, just only explain in detail about what? Multimedia card. About, see, multimedia card is a what? Memory card standard used for what? Solid state storage. So, unveiled in what? 1997 by SanDisk and Siemens AG. So it's going to be looks like that. So this is about MMC card. Okay, yeah. So this media type is what type it is? Memory card type. MMCs are available in sizes up to what? 512 GB. So it is developed by what? JEDEC. See, this is a solid state technology association, is an independent semiconductor engineering trade organization. Okay, so these MMC cards are developed by what? JEDEC. It's what? Is an independent semiconductor engineering trade organization. See, MMC is based on a what? Surface contact low pin count serial interface using a single memory stack substrate assembly and is much smaller than what? Earlier system based on what? High pin count parallel interfaces using traditional surface mount assembly such as what? Compact flash. See, the dimension standards what? 32 into 24 into 1.4 mm. See, generally used for what? Portable devices. Portable means we can carry from one place to another place. Okay, it is extended to what? SD. The MMC next level extension is what? SD cards, secure digital cards. So it varies what? Various types like RSMMC. See, RSMMC, DVMMC, MMC plus, MMC mobile, MMC micro, MI card, secure MMC, eMMC. These are all what? Various variants of what? MMC. See, what is this RSMMC? Stands for what? Reduced size multimedia cards. See, DVMMC stands for what? Dual voltage multimedia cards. MMC plus. Next, MMC mobile. MMC micro, MI card. See these interchangeables. Okay, secure MMC. eMMC is nothing but what? Embedded MMC, multimedia cards. See, these are all what? Various variants of what? MMC cards. See, it is used in what? Almost every context in which memory cards are used, like cellular phones, digital audio players, digital cameras, and PDAs. See the various examples like MMC, RS MMC, MMC Plus, MMC Mobile, Metal Extenders. These are all available in the market about MMC cards, multimedia cards. Okay, available in the market. Okay, so this is about what? MMC. Next we go with what? SD cards. SD stands for what? Secure digital card. Okay, what is SD stands for here? Secure digital card. So is a proprietary non-volatile memory card format developed by the SD Association, SDA, for use in what? Portable devices. Okay, see what SD card is telling is a proprietary non-volatile memory card format developed by the SD Association, SDA, for used in what? Portable devices. See, SD cards looks like that. This is about SanDisk. Okay, 8 GB SDHC card it is. The standard was introduced in what? August 1999 by what? Joint efforts between SanDisk, Panasonic, and Toshiba as an improvement over MMC's multimedia cards. See, SD card is what? Extended of what? MMC. Okay, SD cards are what? Advanced of what? MMC. See, simply we can call it is an extended from what? Multimedia cards. Okay, see, this is extended cards of what? MMC cards. Okay, so media type is what? Memory card. Encoding type is what? Bit type. The capacity is going to be ranges from what? SD, mini SD, micro SD, standard capacity SDSC, high capacity SDHC. So this is about what? High capacity SDHC card it is. Okay, like that in market available extended capacity SDXC, ultra capacity SDUC. Like SD is going to be range up to what? Secure digital cards range up to what? Like generally 2 GB, SDHC over 2 GB to what? 32 GB, SDXC over 32 GB to what? 2 terabytes TB, SDUC over what? 2 terabytes to 128 terabytes. See, I hope all are clear about these memory measurement units. Already in the previous session explained in detail about what is bit, bytes, kilobytes, megabytes, gigabytes, terabytes, right? Yes. See, these SD cards are going to be vary the capacity ranges from what? From GBs to terabytes. See, this is developed by what? Not only one company, like SD Association, SDA, we may call it. Okay. So usage what? Portable device. It is also what? Portable. We can carry from one place to another place. We can connect with one computer to the another computer, such as digital cameras and mobile phones, including what? Most smartphones. So this is about what? SD cards, secure digital cards. Okay. So this is about what? Various types of memory cards and SD cards. Okay, these two comes under what? Memory cards. See, today we discussed in detail about what? Solid state storages, about what? Flash drives and memory cards. In the flash drive we discussed about pen drives and SD MMC cards. See, observe here. Yeah, in the computer memory I explained in clearly about all the topics like registers, different types of registers, characteristics, features, and history. The primary storages we discussed in detail about what? RAM, different types of RAMs like SRAM and DRAMs in the ROM, MROM, PROM, EPROM, EEPROM, and flash ROM, cache memory, and virtual memories. Coming to secondary storages, I explained clearly about what? Various magnetic, like magnetic tape and magnetic disk. The magnetic tape, again we discussed cartridge drives, cassette drive. The magnetic disk I explained about floppy, hard or fixed disks. Okay, the secondary storage device explained in detail about what various optical devices like CD-ROM, warm disk, CDR, CDRW, DVD-ROMs, and a Blu-ray disc. In this session, I explained about what solid-state secondary storages like flash drives or pen drives, memory cards like SD cards, MMC, various different types of cards. Okay, I hope all are clear about what various different types of memory available in what computer. Okay, see, and the last one I try to discuss about how this, what are the various organization of data on a disks. We try to discuss some simple and some major points involved in what organization of data on disks. Like in the previous video session, I explained about hard disk architecture, structures, and components. Similarly, like optical related and solid state also explained, right? Yes. What are the various organization of data on disks? Like tracks, sectors, clusters, cylinders, heads, access time, seek time, transfer time, and latency time. Okay, so I give some brief introduction and a description about what all these organization of data on a disk. See, what is this tracks? See, tracks is nothing but what? Concentric rings. This tracks is nothing but what? Concentric rings called tracks or written on the disk during the formatting process. Like floppy disk have what? 40 or 80 tracks per side, whereas fixed disk like hard disk can have from 300 to over 1000 tracks per side. Okay, in the previous diagrammatically I explained about what is tracks. And coming to sectors, each track is further divided into what? Smaller units called sectors. Sectors are what? Numbered divisions of the tracks designed to make data storage more manageable. See, sector is the basic unit of what? Data storage on a hard disk. A single track typically can have thousands of sectors, and each sector can hold what? More than 512 bytes of data. See, in the previous session also explained. If you want, once again I try to explain. See, this is about what? Platter. In the platter, it's going to be generated what? Several tracks, right? See, this is about what? Tracks. Like n number of tracks are there. See, the each track again it consists what? Each track again it going to be consists what? Sectors. So this is about one sector. Okay, like that. So I try to draw like that. So this is about what? Sectors. Like that. Okay. So directly I'm drawing, but it consists what? Separate sectors. In the previous video session I explained. Okay, like that. Okay. So this area is, we may call it what? Sectors, we may call it. Okay. So this area we may call it what? Sectors. Each track consists what? Sectors. The group of these multiple sectors we may call it what? Clusters. See, now again once again I'm telling the definition. What is tracks here? Tracks is nothing but what? Concentric rings. So this is about what? One track we may call it. See, or written on the disk during the what? Formatting process. What is sector? See, each track is further divided into what? Smaller units called what? Sectors. Assume, so it is a platter, spindle. On that I am going to be dividing like sectors. So this is about what? Sector. Each track again is going to be divided into what? Smaller units. We may call it what? Sectors, we may call it. This is what we may call it sectors. This block, this area we may call it what? Sectors, we may call it. So like multiple sectors are there. The combination of these multiple sectors we may call it what? Clusters. Sectors are often grouped together to form clusters. The group of these sectors we may call it what? Clusters, we may call it. Okay. And cylinders are there. A cylinder is two corresponding tracks on a fixed disk. See, it is the aggregate of all tracks that resides in the same location on every disk surface. Like on a floppy disk, a cylinder compresses the top and corresponding bottom track while storing the data. The operating system files an entire cylinder before moving to the next one. So this is about what? Cylinders. Okay. Next, heads. See, this head is a device that reads data from or writes data to a magnetic disk or tape. See, what is this head? It is a device that reads data from or writes data to a magnetic disk or tape. See, the head becomes what? Like dirty. It will not work properly. See, this is one of the first things to check if your disk drives or tape drives begins to malfunction. Next, access time. See, what is this access time? The average time required to reach a storage location in memory and obtain its contents is called the access time. Okay, next, seek time. Seek time refers to a time a program or a device takes to locate a particular piece of data. See, in electromechanical devices such as disks and tapes, the access time consists of what? Seek time required to position the read write head to a location. Okay, next, transfer time. Time required for transferring the data to or from a particular device. The seek time is usually much longer than the what? Transfer time. Next, latency time. See, in accessing data on a disk, latency is defined as the time it takes to position the proper sectors under the read or write head. See, this become what? Latency time. See, I explained that the organization of data on disk like various tracks, sectors, clusters, cylinders, heads. What is access time? What is seek time? What is transfer time? And what is latency time? So this is what completion of your memories. So in this session, we completed the complete computer memory, including registers, primary storages like RAM, ROM, cache memory, virtual memory. The secondary storages like what? Magnetic, called magnetic tape and magnetic disk, optical storage devices, and solid state storage devices, with including what? Organization of our data on disks. Okay, so that's it for what? Memory session. Okay, see, thank you for watching my videos. Okay, yeah, thank you all.